Electricity and Magnetism. Electric Potential. Lecture 1. Determine the expression of the electric potential at any point outside a uniformly charged contacting sphere. Let's assume charge in free space equal plus q, radius equal a, center of the sphere equal 0. Q equal charge in free space, radius a and center of the sphere equal 0. Let's join OP. Imagine two nearby planes perpendicular to the line OP. These two planes intersect the line OP at point A and B and at point C and D. Radius equal AE, thickness of the ring equal AC. Then radius equal AE and thickness of the ring equal AC. Again let's assume thickness of the ring equal d theta. Thickness of the ring equal d theta. Radius of the ring equal center of the sphere equal theta. Surface density equal sigma. AE equal A sin theta. In this figure, deductively triangle AEO, angle AEO equal 90 degree and angle AOE equal theta. Then we know sin theta equal AE equal perpendicular and hypotenuse equal OE and OE equal radius equal A. Then sin theta equal AE by A and AE equal A sin theta and S equal A d theta, because the actual length S will be S equal R theta. Similarly, S equal A d theta. Circumference equal 2 pi into radius. Then circumference equal 2 pi into A equal 2 pi A sin theta, because A equal A sin theta. Area equals circumference into thickness. 2 pi A sin theta into A d theta, because thickness equal A d theta. Quantity of the charge equal 2 pi A square sin theta d theta into sigma equal 2 pi A square sigma sin theta d theta. From every point of the ring P is equidistant. Let this distance equal x. The electric potential at point P dVp equal 1 by 4 pi epsilon naught into 2 pi A square sigma sin theta d theta by x. Equation number 1. Now triangle OAP from x square equal x square plus r square minus 2ar cos theta, applying Pythagoras theorem. By differentiation equal 2x dx equal 2 pi a sin theta d theta, because a and r equal constant. By differentiation x square equal x square plus r square minus 2ar cos theta. No, ddx of x to the power n equal n x to the power n minus 1. Then 2x to the power 2 minus 1 equal, also know ddx of a equal 0. Then ddx of a square equal 0 plus ddx of r square equal to 0 minus 2ar, and also know ddx of cos theta equal minus sin theta into minus sin theta. In this case cos theta is not x. Then also differentiate theta, we get d theta by dx into d theta by dx, or 2x equal minus into minus equal plus 2ar sin theta d theta by dx, or 2x dx equal 2a sin theta d theta. Then sin theta equal x dx by AR. Equation 1 becomes dVp equal 1 by 4 pi epsilon naught into 2 pi square sigma x dx by AR into x equal 1 by 4 pi epsilon naught 2 pi sigma by r into dx. Equation number 2. Electric potential at point P due to a complex pair. Vp equal integration of dVp equal integration upper limit r plus a and lower limit r minus a into 1 by 4 pi epsilon naught into 2 pi sigma by r into dx. 1 by 4 pi epsilon naught into 2 pi sigma by r is constant. Then 1 by 4 pi epsilon naught into 2 pi sigma by r into integration upper limit r plus a lower limit r minus a dx. We know that integration x to the power n dx equal x to the power n plus 1 by n plus 1. In this case, integration of dx equal integration of 1 into dx. And we know x to the power 0 equal 1. Then x to the power integration of x to the power 0 into dx, x to the power 0 plus 1 by 0 plus 1 equal x. Then 1 by 4 pi epsilon naught into 2 pi a sigma by r into x upper limit r plus a lower limit r minus a. 1 by 4 pi epsilon naught into 2 pi a sigma by r into upper limit minus lower limit. Upper limit r plus a minus r minus a equal r plus a minus a plus a minus a plus a equal 2a. Then 1 by 4 pi epsilon naught into 2 pi a sigma by r into 2a. 1 by 4 pi epsilon naught into 4 pi a square sigma by r equal 1 by 4 pi epsilon naught into q by r, because total charge equal 4 pi a square sigma equal q. This is the required expression. End.